So as a continuation from the previous video, we are looking at the compound interest formula, and we are going to try and find different parts. So we've already done future value, we've done the rate, but now if we want to find the years, which is the n. Now this is a power, so we'll have to use different techniques to solve it. So looking into here, saying invest 20,000 Egyptian pounds in the bank that offers a rate of 3.1 per annum compounded monthly. The first part is just asking for the amount. So for part A, we want the future value. We know that the present value is 20,000. The rate is 3.4. The N is 5 years, and the K, it's compounded monthly, so our K is 12. Putting this into the formula, we're going to get 20,000 1 plus 3.1 divided by 12 times 100. Remember, it's k times 100 to the power of 12 times 5. So make sure you multiply all the proper values together. Plugging this into the calculator, again, I'd recommend you do these step by step. So complete the 12 times 100, even if it's painful, but at least you'll guarantee you get the right answer. Complete 12 by 10 in your calculator. Then take 3.1 divided by that. Then please remember to add 1 to your answer. Once you've done that, then raise your answer to the power of 12 times 5. I've seen students forget to multiply these. And then remember in the end to multiply it by 20,000. So make sure you do all of these steps. You should get as a final answer, this will be 23,348.49 Egyptian pounds. So that's for part A. So part B asks how many years, so we're looking at N, and I mentioned in the end of the previous video that they will rarely ask you for K, or actually never, because it's too complicated to find since it's in the denominator and the power. So we are looking at years, which is N. So find how many years it would take for this money to double. For his money to double, we're looking at his actual money. This is only after 5 years, but I want to know how long would this money take to double. So please keep in mind when what value you're taking initially. So his money is 20,000. The 23,000 is only after 5 years, but his money is 20,000. So if I have the future value, I want my future value to be 40,000. So that's his money doubling. And then our present value is 20,000. The rate is still the same. The N is unknown, and the K will stay the same. So plugging this into the formula, we get 40,000, and then we have 2,000. 1 plus 3.1 divided by 12 times 100 to the power of 12 times N this time. Now, to solve this, you have to first simplify everything. As many numbers as possible, just simplify them. So I can get rid of this 20,000, so I'll divide by 20,000 here, 20,000 there, so I'm going to get 40,000 divided by 20,000. And this will be 3.1 divided by 12 times 100 to the power of 12n. Now this part will simplify to 2, because remember it's double. So this will be 2. I can also simplify whatever's inside the bracket. So 3.1 divided by 12 times 100 is, and then add the 1. So the power is going to be 1.00258. I'm just writing as many decimal places as possible. But when you're doing the calculation, just use the original number in the calculator. Now, when you're faced with this situation and you have a power, you can't root just yet. What you will do is use logs. You're going to take the log of your answer here, and you're going to divide it by the log of your base, which is raised to the power. Whatever is being raised to the power that you want to find will always go in the denominator. Just remember that. And this will be equal to whatever you have here. So that's 12n. Exactly as you have it here, you're going to plug it in there. Now try to find log in your calculator, and log of 2 divided by log of our answer will be 268.66 equals to 12n. Now it doesn't make sense to have this as years, and yes, it doesn't make sense because it's 12 times the n years. So you'll have to divide by 12, and this will give you as n equal to 22.388, which is about 22.4 years. Now, you will notice that the calculator will give you two answers. It will either say 22.4 years, sorry, the book will give you 22.4 years or 23 years. Now, another way to do this is to go on your calculator and what you're going to do is, for example, this is a different technique to use if you want to. And what you can do is plug in this value, this equation in. So you're going to go 1.00258 and to the power of 12x. You can also plug this first one in, but then you'll have to, or even the beginning, but then you'll have to match it with 40,000. This is just much simpler to look at. Now, once you've done that, you're going to go second table. So you press second table, and then you're going to look at which x would give you, which x, and our x is n, would give you a y that's almost equal to 2. So if we scroll down, so the closest number that will get you to a 2 is not 22. 22 is still less, so it's actually 23. So that's why the book might give you an answer of 23. It's because if you use the calculator, you'd pick an answer of 23. So if you plug in 23 in here, it's going to give you the y equals to 2. If you did the same thing here, you wrote 20,000, 1 plus 3.1 over 12 times 100 to the power of 12 times x, or 12x, and then you look down at the x and see which y value would give you 40,000, then it would be something close to 23. It wouldn't be 22 again because 22 is still less. The more accurate answer is 22.4. This is the more complicated one in terms of the power. Just remember to use logs. Now, finding the present value is much easier than it seems. It's a matter of simplifying. In this question, a bank is offering a rate of 6% per annum compounded monthly. Mr. Brunt invests X pounds in his bank, and the amount of money in his accounts after 5 years is 40,000. Calculate the value of X. So our future value is 40,000. Our present value is unknown. Our rate is 6. The years is 5, and the K is compounded monthly, so the K is 12. Plugging this into the formula, we have 4,000 equals to X, and then 1 plus 6 over 12 times 100 to the power of 12 times 5. It's pretty simple and pretty straightforward. You just simplify all of this. So I'm going to do it step by step, but you don't have to do it in those steps. So I'm just going to go 6 divided by 12 times 100 will give me 0.005. And then the power will be 60. And this will be 1.005. Again, you don't have to do it in such a long method. I'm just showing you how the simplification happens. This whole thing will be 1.34885. And then if I want to get rid of this and I want to find x, obviously I'll have to divide it by 4,000. So 4,000 divided by this whole mess, and you're going to get x. And so your x is equal to 2965.48878 5. This is the full answer. Now they want correct to the nearest pound, so I'll have to round it to 2,965, and that's Great British Pound. For part C, I took this, there was a part A in this question, so ignore the part. So for part C, calculate the number of years that it would take for Mrs. Alcott's money to double. So her money is this, remember, this is her initial money, and we want to know how long it's going to take to double, so that's another case for N. I'm going to have you try and solve it, and if you pause the video and unpause, I'm going to tell you the answer. So if you do it by log, you're going to get the N equal to 11.6. If you're going to do it by GDC, you'll get an answer where N is equal to 12. Hopefully the videos were clear and useful. Just make sure you are clear with where to substitute and how to simplify with each part, and practice as many questions as possible.